can be taken for partial fraction expansion. So right now, let me quickly take partial fraction expansion. This will look something like this: a upon z minus 1 plus b upon z minus 2 plus c upon z minus half. So now I will just cross multiply on both the sides to be able to find a, b, c. Y of z by z was that whole thing. So if I just cross multiply, it will give me, and now one by one we can find out the values of a, b, c. So we will put z equal to 1 on both the side. When z is equal to 1, you get 3 minus 7 plus 5 equal to a into, this will be 1 minus 2 into 1 minus half. The remaining terms, you can see 1 minus 1 will become 0. So this will give you the value of a. If you solve this, this is 8 minus 7, which is 1. And here you get 1 minus 2, which will be minus 1. And 1 minus half will be half. So that's minus half. What goes on the other side will be minus 2. So a becomes minus 2. Next, I'll put z equal to 2. Z equal to 2 will give me 3 into 2 squared minus 7 into 2 plus 5 equal to. So we are putting these values in this equation. On the right hand side here, 2 minus 2 will become 0. First term will become 0. The second term will be 2 minus 1 into 2 minus half. And the third term will also become 0 because 2 minus 2 is 0. So if you solve this, you get b equal to, on this side you have 4 into 3, 12 minus 14, which is minus 2 plus 5 is 3. And that gets divided by, this is 1, and 2 minus half will be nothing but 3 by 2. So 3 will cancel out and b will become 2. If I now put z equal to half, then I get 3 into half squared minus 7 into half plus 5. And this will be equal to, this time half minus half, first term will be 0, second term will also be 0. You will have third term, half minus 1 into half minus 2. So similarly, if you solve this equation, because there's only one unknown c will come out to be equal to 3. So based on that, my whole thing will now, we have got the values of a, b, c. So I'll write down this expression once again. So y of z upon z will become, so minus 2 upon z minus 1 plus 2 upon z minus 2 plus c will be 3 upon z minus half. And now we will send that z on the other side. So we get y of z equal to minus 2z upon z minus 1 plus 2z upon z minus 2 plus 3z upon z minus half. So if you now observe, I can easily take inverse z transform, because all these three terms that we have got are of the form z upon z minus a. And for z upon z minus a, the inverse z transform was a raised to n up u of n. But this is obviously assuming the signal to be causal. In this case, we will assume system to be causal because all the practical systems are causal systems. So henceforth, this will be a default assumption. We will be assuming all the given systems to be causal, because digital signal processing is all about analysis of the practical systems, and all the practical systems have to be causal system. So assuming system to be causal, system is causal, and one more thing, the input signal that was given to us is also causal, because x of n equal to u of n. U of n is a causal signal. So when these two things match, then output y of n has to be causal. So we will take inverse z transform, which is causal in nature. So all these constants will be kept as it is. Minus 2 remains as it is. Z upon z minus 1 is nothing but z transform of u of n. 2 into z upon z minus 2 is z transform of 2 raised to n u of n. And this is 3 into half raised to n u of n. So that's my output y of n. So this is what we were looking for. But if you remember, this was a question without considering any initial conditions. The initial conditions were equal to 0. Let us now look at one example where initial conditions will be given.